Okay, so welcome to week 12. Today we're going to be doing percentage mass, but before we get into that, there's been a few comments about screen quality and resolution and things like that. So we're going to try something else today. I'm going to try and keep my face down there because my face has always been moving about, and I'm going to try and move this and zoom in rather than the way we've been doing it. So I'm going to try something else today. Comment below if you like this way of doing it. It's hard to look at me and make eye contact at the same time, so I'll be doing that a lot. So let's get on with the starter. You are going to need a periodic table for this lesson. Now you'll find one on the Teams drive, because you'll see there question 4. You're going to require a periodic table. I wouldn't recommend getting one from the internet, because sometimes they've only got one number and you don't know if that's the atomic number or the proton number, so be careful. Use the one that's on the drive, okay? So press pause, have a go at the starter. You can see the challenge there is the question from last week's work, which some of you found challenging. I know it was a difficult topic, but we have to do these topics, okay? So press pause, have a go. All right, so I am a positive subatomic particle found in the nucleus of an atom. I am a proton. Remain positive and think like a proton. I only allow certain substances to pass through the cell. I am a cell membrane. I can actually do it with this now. I am the second planet from the sun, so my very Venus. I am found in group 6, period 2, so you'd need the periodic table there. It's going to be oxygen. I am a biological catalyst. You may have needed to use the internet for that, or Google. I am an enzyme. You will find me in the first column of a table and the bottom of a graph. This goes right the way back to, I think it was week 7, we was doing graphs. And you'll know on the bottom is the independent variable. And you've got your challenge here. Brown eyes are dominant. So I said brown is a capital B over green eyes. So green must be recessive. A homozygous recessive male. So the male is both recessive, because he's homozygous, the same, is crossed with a homozygous, the same, dominant, big letters, capital letters, female. So there's your female. Predict the probability their offspring will have green eyes. Now remember, green eyes is the recessive. So when I do this Punnett square, okay, actually there is 0% green eyes, because you get a big capital letter in each of these offspring. So there's absolutely no chance there's going to be green eyes. They're all going to be brown, because they're all going to be displaying in their phenotype brown eyes. So today we are going to be learning about molecular mass and how to formulate the percentage mass of an element in a compound. Some of you would have done this already, but it's a really good recap. Year 8s would have done this. Year 7s wouldn't have done this. But again, I've got every confidence that if you follow the method, it's nothing too difficult. You just need to listen and follow the steps. I put a learning journey together this week, because in previous weeks we have been doing a step-by-step, and I think it's nice to know what we're going to be doing in advance. So first of all, we're just going to be counting atoms. This to me is quite easy, accessible to anyone so long as you listen. Calculate the MR. That again is very achievable, providing you've got the periodic table. And then the percentage mass, maybe then more aimed towards the key stage for year 9 and 10s. But as I always say, year 7s and 8s have a crack. You're losing nothing. And then the assignment. So we've got the keywords there: molecular, percentage, and divide. And the first thing you are going to need, like I said, is the periodic table. This is the periodic table from the exam board. This is the one I would recommend downloading, or even taking a photo of it while you do the work, so you can just zoom in and zoom out. It's totally accessible. Okay, so there shouldn't be any excuses here with the technology available today. So let's just recap here. These big numbers and small numbers, they do vary. Sometimes they're on top, sometimes they're on the bottom. So the important thing is to look out for the big number. The big number is the mass number. It contains the number of protons and neutrons. And the small number only tells you the number of protons or, and that's a very important or, electrons, because it's not electrons plus neutrons. Whereas this mass number is protons plus neutrons. Today, we're going to be using the big number. So in previous, when we did electronic structure and we drew the electron configuration, we were using the small number. But today we're going to be using the mass number, hence the term molecular mass, and MR. So we're just going to recap on counting atoms here. Just going to take a sip of tea. Now, we've got lowercase numbers after some of these letters. Now, these letters represent symbols found in the periodic table. So H would be hydrogen, O would be oxygen. If you want to check that on the periodic table, you can. There's always a little number, and it's lower, not lowercase, what's it called? I can't think of the word now, superscript and subscript. Subscript. We've got to be careful, especially when we're writing these. Some students write this superscript, but this is always subscript. And if you always see a subscript, what that means is that little 2 sort of below the line that you write on, after the element, it means that there's going to be 2 of these hydrogens, not 2 of the oxygens. It's always after. It's always after. So if you see a number after this, the symbol of the element, it means that there's 2 of them. For example, in this case here, CO2, there's only 2 oxygens because there's no number after carbon. So there's only 1 carbon. And let's do this. I'll show you how it's done. So the first thing I'm going to do is I'm going to circle up, okay, these like that. So now I know there's 2 hydrogens plus 1 oxygen, because there's no number after oxygen. Let's do the next one. Well, I've got a hydrogen and I've got a chlorine. Chlorine is the hardest one because you could also interpret that to be HC capital I. The other thing I should mention here is that we're always looking for capital letters at the start of an element. If there's a lowercase letter next to the element, it's part of the same element. For example, argon is A, capital A, small r. Okay, so you've got 2 letters. Helium, H, small e, lowercase e. So we're always looking for the start of a capital. Just get rid of that now. Now, HCl, you've just got to become familiar with having Cl, because when I've been in class and done this before, people have circled HC and then thought that was an I, but it's not. It's a Cl. So we've got 1 H and 1 Cl. So that's equal to, sorry, that should have equaled 3 there. So I've got 3 atoms here. I've got 2 atoms here. I've got 1 carbon. And then I've got 2 oxygens. So that equals 3 there. O2. Well, I've just got 2 atoms. Yeah, 2 atoms of oxygen. Here's a bigger one. I've got my H, my S, and my O. So I've got 2 hydrogens. I've only got 1 sulfur, S, because there's no number after it. So I've got 1 S, and I've got 4 oxygens, because there's a number 4 after oxygen. Oops. Let me just do that again. I've got 4 oxygens. 2 plus 1 is 3, plus 4 is 7. Have a go with this yourself. On the next slide, see how we do. Press pause. Let's see how we did. So I've got 1 carbon, 4 hydrogens, that's 5. 2 hydrogens, 2 oxygens, that's 4. 1 nitrogen, because there's no number after it. 3 hydrogens, that's 4. Here's an example of that lowercase letter now. So Na is sodium, so that's all 1. That's 1. O, 2, H, 3. So there's 3 atoms there, because there's no numbers. Then your challenge. So I've got K, potassium, chlorine, 1, and then oxygen, 3, that's 5. And then this was a real solid one, but if there's a number outside of brackets, that means that is times 2 everything inside these brackets. Okay, so I've got 1 sulfur and 4 oxygens, that's 5. And then outside the brackets is times 2, so 2 times 5 is 10, plus my 2 calciums. So that's just a bit of a recap on counting atoms. Okay, that's not part of the process today, but it's nice to be able to separate these atoms up, because that's what we're going to be doing when we come to do MR. So we're just going to practice MR now. This is the next thing we're going to practice. So just to be a recap on calculating, oops, I didn't want to do that. Sorry, and calculating MR. So I'm going to do one for you. You can see I'm going to go through the success criteria first. Circle the different elements and their numbers. So that's kind of what we've just been practicing. Identify the elements. So we're going to have to use a periodic table for this. There's your periodic table, because you're going to have to get that mass number. Identify how many elements you have. So let's go through this together. So circle the different. So my step 1, I'm going to circle the different elements. So I've got C and I've got O2, and then identify these elements. So I'm going to go C and then O. Okay. Step 3, identify how many elements you have. Hint, the little number tells you how many you have. So I've got 1 carbon, because there's nothing, no number after carbon. And then for oxygen, I've got 2 after the number of oxygen, so I've got 2 oxygens. Find the massive number. Find the mass number now of each element. So you look up in the periodic table. So I'm going to go to my periodic table. I'm going to do carbon first. So I know carbon's over here. Well, my big number is 12. So I'm going to go back now and write 12 there. And then for my oxygen, well, I just know I've done it so many times, it's 16, but I'll show you. There it is, big number 16, okay? Go back, 16. And then use a calculator and times how many by the massive number. Well, I'm not going to use a calculator in this time, because 1 times 12 is 12, 2 times 16 is 32. And then the last step, add up the total column. So my MR equals 12 plus 32. So that's going to be 44. Okay, so that's your MR done. Okay, let's do another one together. CH4. First thing I do is circle the elements. So I got my C and I've got my H with the number. Identify the elements. So C, H. How many have I got? Well, I've got 1 carbon. There. Got 1 carbon. And I've got 4 hydrogens. What's the mass number of carbon? It's 12. We just did it. Again, I'd recommend you check the periodic table, but just to make this video quicker, I'm just going to put 12. Hydrogen's first element in the periodic table. It's got a mass number of 1. What's the total? 1 times 12 is 12. 4 times 1 is 4. Last step, add up the total. So I'm going to be doing my MR as 12 plus 4 equals 16. Very good. I think we've got one more practice together. Oh no. So you've got now, try it and press pause. Let me just try and make that bigger. H2O. Have a go. See how you do. Lovely. So I've got 2 hydrogens. So I've identified my atoms there, H and O, H and O. I've got 2 hydrogens. I got 1 oxygen because there's no number after oxygen. I've got a mass number of 1 for hydrogen and a mass number of 16 for oxygen. So 2 times 1 is 2, 1 times 16 is 16. Add the total columns up, so that's 2 plus 16 is 18. And that's my MR. So if you're not getting this, I would recommend you go back a couple of minutes, watch me do it again, or even search YouTube for calculating MR. There are people out there that can break this down, maybe, probably better than me. You're not going to get it first time. If you don't get it first time, don't do the email saying, I just don't get it. Just by watching it first time, like riding a bike or doing a skateboard trick or anything in life, everything takes practice. And just because you don't get it first time doesn't mean you can give up on it, because that's not the way it works, okay? You've got to put some effort in if you want the rewards. So if you want to learn this subject and you want to do well at GCSE, you've got to put the work in. So if you don't understand first time, go back. If you don't understand then, go and watch another video. It's really important that you take control of your own education. Okay, so there's the periodic table again. Percentage mass now, so one step further. So we've counted atoms, we've calculated MR. Now we want to find how much of something is in something. For example, we could say, so Mr. Timothy is made up of bone and hair and fat. How much fat has Mr. Timothy got? Now, don't comment the answer down below, because that would be embarrassing. But it's the same principle. How much of something else got? So when we're looking at hydrogen there, okay, it's just hydrogen. An element that you can't break it down anymore. They're atoms, okay? An element has all the same atoms. But when we're dealing with compounds, okay, 2 or more elements chemically bonded, like water, it's got hydrogen and oxygen. Well, I wonder how much hydrogen is in oxygen. Well, I know it tells us that there's 2 atoms of hydrogen for every 1 oxygen there. But hydrogen is very, very light, isn't it? It's got a mass number of 1. Whereas oxygen has got a mass number of 16. So it's quite heavy compared to hydrogen. So in terms of the bulk, oxygen is probably going to make up the most of that compound of water, that molecule of water there. Let's look at glucose there. You've got 6 carbons for 12 hydrogens for 6 oxygens. Now, carbon's got a mass number of 12, and oxygen's got a mass number of 16, so they're quite heavy elements. But then I've got 12 of these little hydrogens. So it's interesting to know how much of something makes up something else, if that makes sense. And we can do that. We can do that using the periodic table, and I'll show you how. It's a process. So calculate the percentage composition of hydrogen. So the first thing I want to do here is, so it says draw my table, but for key stage 4 you're going to have to draw a table. For key stage 3 I'm going to give you the tables. Circle the different elements and their numbers. So it's kind of the same process as we was doing here. So I've got my hydrogen and I've got my oxygen. And then it says identify the elements. So I'm going to do this the same again. I've got my hydrogen and my oxygen. And then step 4, identify how many elements you have. So same process so far. So I've got 2 hydrogens, because I've got a number 2 after hydrogen, and I've got 1 oxygen. We've done this in an example before, I think. Oxygen. Identify how many elements you have, hint, little number, right. Find the massive number of each one. So use your periodic table. So I know hydrogen's worth 1, I know oxygen's worth 16. My mass numbers, my big numbers. Where is it? So go back to your oxygen, my 16, that's where I'm getting it from, okay, just in case you're wondering. And then step 6, use calculate to calculate how many there are. Mr. Woolley would have a kitten if we did that. But it's very important in exams that you do use calculators. I can't stress enough, because even the simplest calculation, like 32 adding 32, okay, there are mistakes to be made there sometimes, so just use a calculator. If it's in the exam, use it. I know in lessons you can practice your numeracy, but I really stress in an exam, use your calculator. So 2 times 1 is 2, 1 times 16 is 16, 16 plus 2 is 18. Now, watch what I do here. I'm not going to put 18 in the elements MR. I'm not going to do that. I'm going to say total MR is 18. That's my total MR. A couple more steps now. So it says, add up the total, this gives you, circle and highlight the mass of the element you are calculating. So I need to go back to the question now and have a look. Calculate the percentage of composition of hydrogen. So what's my mass of hydrogen? Well, I've got 2 times 1, which is 2. So that comes down, so my element's mass is 2. Okay? It's a very important step, that. Because no matter which one it tells you, it could have said calculate percentage of oxygen, and then I would have circled oxygen, and then I would have brought that down. Okay? So this is going to be now divided by, I know it's not quite clear here, but 2 divided by 18 times 100. So that it literally is 2 over 18. So if I shifted that 18 across there, and then times by 100, because it's a percentage. So 2 divided by 18 times 100. I'm actually going to use my calculator for this on my phone. So 2 divided by 18 is 0.11, so it's going to be 11%. Okay? It's going to be 11%. I'll just times it by 100 just to check myself. It is 11.1%. I'm just going to go to an integer there, a whole number. Okay, so it's 11% of water is hydrogen, if that makes sense. Okay, so if for every molecule of water is 11% of hydrogen, therefore the remaining percent is oxygen, whatever that is. I don't know. Comment below. Okay, what do you think that is? Let's have another practice. Let's do a WeDo now. CO2. So I'm going to go through these steps quite quickly now to keep the video fairly short. So I've got a C and I've got an O. I've got one C. I've got 2 O's. because there's a 2 after O. My C is worth 12. My oxygen is worth 16. Okay, use the periodic table to check. I'm using all these elements to keep them quite familiar, and all the same elements keep them quite familiar. 1 times 12 is 12. 2 times 16 is 32. So 12 plus 32 is 44. I'm going to put that now under that line, 44. Total MR 44. Calculate the percentage composition now. So we're going to, I think we're on step 8 now. Circle and highlight the mass of the element you are calculating. So I'm doing oxygen. That's what it wants in the question. Oxygen is 32. It's going to be 32 over 44 times by 100. So I'll just write that out. 32 over 44 because times 100 because it's a percentage. I'm going to use my calculator here. I got my phone. It's 32 divided by 44 comes out to be 0.727. So that's 72%. So look, times 100. So 72.7%. Now I can either write it like that or I'm going to round it up to 73%. 73%, okay? I think we've got one more WeDo, and I'm just going to race through this now. CH4. I've got one C, I've got H, and I've got 4 of them. My mass number for carbon is 12. My mass number for hydrogen is 1. 1 times 12 is 12. 4 times 1 is 4. My total MR is 12 plus 4, which is 16. What's the element that I want? I want to know how much hydrogen is in there. So hydrogen is 4. 4 over 16 times 100, because it's a percentage. Use my calculator. 4 divided by 16 equals 0.25 times 100 is 25%. So of that methane, that's CH4, 25% of that is hydrogen, and the rest is carbon. Have a go with this, see how you do. There's the periodic table again. Okay, and try it, press pause. So this is what I've got. I've actually gone to a decimal place here. I don't know why. That should have been 18% really. I'll rewrite that as 18%. So I've got 1 nitrogen. I've got 3 hydrogens. Nitrogen's worth 14 from the periodic table. Hydrogen's worth 1. 14 plus 3 is 17. I want to know hydrogen. So hydrogen is 3. Just circle that up. 3 over 17 times 100 is 18%. And that's my MR. Sorry, that's my percentage mass. All right then, let's look at the assignment, because I want to keep this video quite quick. It says complete on a piece of paper or, and photograph, or you can download the PowerPoint in this case. There is benefits to downloading the PowerPoint in this case because of that periodic table. You'll need access to the periodic table, obviously. Use the layout that I've shown. So for Key Stage 3, you're going to be given, so you need to download this, the boxes, or it's just a simple case of writing it out. You don't even need the table, you just need to write it out in that format. So, you know, identify your element, how many have you got, what's the mass number, that sort of thing. Nice and clear, especially in exam, because examiners love process, okay? You get marks for process. There's 6 questions for Key Stage 3, year 7 and 8, and there's 6 questions for Key Stage 4, year 9 and 10. And then you've got 3 challenges right at the end. So I'm not going to be doing the first one with you because I think I've done enough examples. So go back and look over the examples if you're not sure. Again, I would challenge you to do them all because, you know, we're off anyway. If you're getting bored of the PlayStation or the Xbox, just do all 12 questions or 15 questions with the challenge. Submit it, see how you do. It's just something to do. It's problem solving. Keep you occupied for half hour. So let's have a look at Key Stage 3. So Key Stage 3, we've got 3 questions here. I'm just going to minimize. Oh, I can do this. So there we go. A bit smaller now, look. A bit smaller there now. So there's 3 questions there. And then, ignore the we do hinge because it was used back in another lesson. So we'll call that 1, 2, 3. Okay. And then your next questions. 4, 5, 6. 4, 5, 6. There. So we got magnesium oxide, hydrochloric acid, and sodium fluoride there. Lovely, lovely. So that's your Key Stage 3. And then I've just chucked the periodic table in there just in case you want to press pause and have a look. And then we've got your Key Stage 4 on one sheet. So this time you're going to have to draw the boxes, but it shouldn't be any problem there. And if there is, watch the video again. And if there's still a problem, watch other videos, because you're going to need to know this. And I think that is it. I think the next slide then was answers, which we need to take off the original PowerPoint. But thank you very much for watching. I hope this, let me just do that again now. So I hope this format is better and that it solves the problem of pixels and quality of, you know, accessing this. Again, I appreciate some of you only got mobile phones and you're trying to read the questions, but it's honestly about the best we can do. If you're struggling to see the questions, download the PowerPoint from Teams and maybe follow along with the video, okay? There are ways to do it. I really feel that you would be making an excuse if you just say, look, I just can't do it. I can't see what's going on, okay? To me, that is, you know, I believe if you want to do it, you'll do it. And that's, you know, just the way of life. So, keep safe.